the method of deduction. The method of deduction. You see, unlike the truth table, which can be used to determine whether an argument is either valid or invalid, the method of deduction is applicable only to arguments that are already known to be valid. Which means that if an argument is invalid, you cannot provide any form of proof for that argument. So this method of deduction is also employs the rules of inference. The rules of inference. The rules of inference are a group of argument forms that are already known to be valid. And you know that if an argument is valid, any other argument that takes the form of that argument will be valid. So we employ the rules of inference in providing justifications for arguments that are already known to be valid. You see, if an argument is valid, it is possible to derive its conclusion from its premises. So that's exactly what these rules are meant to do, to help us deduce the conclusion of an argument from its premises. These rules, we are going to be looking at 9 of them. The rules of inference. We're looking at 9 of them. The first one is modus ponens. Modus ponens. MP is abbreviated as MP because when we begin to provide proof for arguments, we'll be using the abbreviations, not the full names. We'll be using MP. Where you see MP, you know we are talking about modus ponens. Now, this is what the rule says. P conditional Q, P therefore Q. This rule is simply saying that if you have in an argument where the first premise, you have a premise that is a conditional statement, such as P conditional Q, and then you have another premise that is an affirmation of the antecedent of the first. You see, this is P conditional Q. This is an affirmation of the antecedent of this first premise. Then you can infer on your own a conclusion that is an affirmation of the consequent of that first premise. You see that? So an example is simply, if John read, P, John read, if John read, then John passed his exams. You see that? This is a conditional statement. If John read, then John passed his exams. And then you have another premise that says John read, which is P. You see, it's an affirmation of the antecedent of if John read, then John passed his exam. John read is an affirmation of the antecedent. Then you can infer a conclusion on your own that is an affirmation of the consequent, which is therefore John passed his exams. So if John read, then John passed his exams. John read, therefore John passed his exams. So this is a valid argument and it follows. The conclusion follows from the premises. This is modus ponens. And then we have modus tollens. Modus tollens, MT. MT. Here, we're also saying that if you have an argument that is a conditional statement, you see, the first premise is a conditional statement, and then you have, as a second premise, a negation of the consequent. A negation of the consequent. Then you can infer on your own a conclusion that is a negation of the antecedent. So P conditional Q, negation Q, therefore negation P. Mind you, you cannot say P conditional Q, negation P, and then you say therefore negation Q. It will not be valid. That is not modus tollens. You can only have a negation of the consequent. That is why it is sometimes referred to as denying the consequent, while modus ponens is referred to as affirming the antecedent. So P conditional Q, negation Q, therefore negation P. So if John read, then John passed his exams. John did not pass his exams. So you can infer necessarily a conclusion that says, therefore, John did not read. See that? If John read, then John passed his exams. John did not pass his exams, therefore, John did not read. Necessary. That's a necessary conclusion. It's a valid argument. It follows. The conclusion follows from the premises. This is modus tollens. So if John read, then John passed his exams. John did not pass his exams, therefore John did not read. Then we have hypothetical syllogism. Hypothetical syllogism. Now, this is simply saying, you see, P conditional Q, Q conditional R, therefore P conditional R. Now, for hypothetical syllogism, we are saying that you must have two conditional statements as premises. Premise 1 is a conditional statement. Premise 2 is a conditional statement. You must also understand that the consequence of the first must be the antecedent of the second before you can draw hypothetical syllogism. If the consequence of the first line is not the antecedent of the second one, it is not possible to draw hypothetical syllogism. Let's say here you have P conditional Q and here you have S conditional R. You cannot draw hypothetical syllogism because the consequence of the first is not the consequence of the second, not the antecedent of the second. This relationship must be present. This relationship must be present before you can draw hypothetical syllogism. So if you have two premises that have this relationship, then you can infer a conditional statement that is a combination of the antecedent of the first premise and the consequence of the second premise. So if John read, then John passed his exams. If John passed his exams, then John gets a scholarship. John got a scholarship. You see that? If John read, then John passed his exams. If John passed his exams, then John got a scholarship. You can therefore have a conclusion that says, if John read, then John got a scholarship. That is hypothetical syllogism. We have disjunctive syllogism. For disjunctive syllogism, you see, you have a disjunction. You have a disjunction. Now, a disjunction as the premise of an argument. And then you have another line that is a negation of any of the disjuncts. That's why you see we have either this or this. Both of them. They are disjunctive syllogisms. So you have P wedge Q, negation P, therefore Q. And here you have P wedge Q, negation Q, therefore P. You see that? So take note of this. For disjunctive syllogism, when you have a disjunction as a premise of an argument, you must have a negation first, a negation of any of the disjuncts, before you can move on to draw a conclusion that is an affirmation of the other disjunct. There must be a negation first. Here, after the disjunction, you must have a negation. After the disjunction, you must have a negation. You cannot have P wedge Q, then you say Q, therefore negation P. No, you cannot affirm before denying. You must have a negation before drawing a conclusion that is an affirmation. Your conclusion must be affirmative. Your conclusion must be affirmative. And then you must have a negation of any of the disjuncts before you can draw that affirmation. So either this or this. It is not P, therefore Q. If it is either this or this and it is not this one, then it's this. If it is either P or Q and it is not Q, then it's P. This is disjunctive syllogism. So either John read or John passed his exams. John did not read, therefore John passed his exams. Or either John read or John passed his exams. John did not pass his exams, therefore John read. So it's either of them, either this or this. That is what it's saying. Simplification. For simplification, you have two statements joined with a conjunction. So it's a conjunction. And it's simply saying that when you have a conjunction, you can take any of them. You can take any of the conjuncts. So P dot Q, you can therefore say P, or P dot Q, you can say Q. That's it. So if you have two statements joined with a conjunction, you can take any of them. Mind you, they must be joined with a conjunction. It is only a conjunction that can be simplified, and then you take any of the conjuncts. So John read and John passes exams. Therefore, John read. Or John read and John passes exams. Therefore, John passes exams. So for addition is simply saying that if you have any statement, no matter how simple or complex, if you have any statement, you can add anything to it. You can add anything to it provided that thing is relevant. Whatsoever statement you are adding to it is relevant, you can add it. And also, you can have two statements in an argument, and then you can bring them together with the aid of addition. You can just have, if you have P and there is Q anywhere in the argument, you can bring Q to P, and then you have addition. But mind you, your conclusion must be a disjunction in terms of addition. Your conclusion must be a disjunction. So you have P, therefore P wedge Q. Or you have P, you have Q, and then you say therefore P wedge Q. You see that? So John read, therefore either John read or John passes exams. Or John read, John passes exams, therefore either John read or John passed his exams. Now you have a conjunction. For conjunction, you must have two statements present in the argument, two different statements present in the argument, so that you have P as a premise, Q as a premise, and then you bring them together with the dot. Conjunction. You bring them together, that's a conjunction. So John read, John passed his exams, therefore John read and John passed his exams. This is a conjunction. And then we have constructive dilemma. For constructive dilemma, we are saying that you must have two conditional statements that are joined with a conjunction sign. Two conditional statements joined with a conjunction as a premise. This is a premise. And then you should have as another premise a disjunction of their antecedents. A disjunction of their antecedents. P wedge Q. This is the antecedent of this statement. This is the antecedent of this statement. So you should have another premise that is a disjunction of their antecedents. And then you can infer as your conclusion a disjunction of their consequence. A disjunction of their consequence. That is constructive dilemma. If John read, then John passed. If John read, then John passes exams. And if John got a scholarship, then John graduated from the university. Then you have a premise which says either John read or John got a scholarship. Therefore, if John passed his exams, therefore either John passed his exams or John graduated from the university. You see that? Look at it properly here. If John read, then John passed his exams. And if John got a scholarship, then John graduated from the university. Either John read or John got a scholarship. Therefore, either John passed his exams or John graduated from the university. And then we have destructive dilemma. DD, destructive dilemma, is still conditional statement. Two conditional statements joined with a conjunction. But this time around, you must have another premise that is a negation of a disjunction of their consequence. It's different from constructive dilemma, which is a disjunction of their antecedents. But here you must have another premise that is a disjunction of the negation of their consequence. And then you can infer as a conclusion a disjunction of the negation of their antecedents. You see that? So, if John read, then John passed his exams. If John got a scholarship, then John graduated from the university. Here, if John did not pass his exams, either John, because it is disjunction, either John did not pass his exams or John did not graduate from the university. You can draw a conclusion that says now that either John did not read or John did not get a scholarship. So that is destructive dilemma. So this is what we have for the rules of inference. The rules of inference. So we'll move on now to try to see how we can provide proofs for arguments using the rules of inference.